So I'm a senior software engineer with a company called VCE, and we've had the opportunity to build several AngularJS applications ranging in size and progressively getting bigger and bigger. Now, the talk is a little bit of a misnomer when I say enterprise scale. Really, I'm just talking about if you're building large-scale applications or applications that are geared towards, developed by a distributed team, this might be relevant to you. And if you're not an AngularJS developer, don't worry about that. There's topics that kind of span JavaScript, and modularity is kind of the key focus of this. So we'll go ahead and get started. My Twitter is John Fontanez, so if you have any questions either after the session or we can have a Q&A, and obviously you can reach me there. So the topics I want to cover are modularity and kind of defining what exactly is the scope of this talk. Some of the architecture that we put in place currently within our applications to really cover that modularity. The problem statement, so understanding what is the thing that we're trying to solve, and then we'll follow that up by actually trying to design some sort of modular AngularJS project, and the life cycle for that would be extending, packaging, maintaining, and some future considerations. So there's a lot to cover in this talk. Hopefully, there will be parts and pieces that are relevant if you're developing an AngularJS application. Overall, the theme, again, is modularity. And if you're not developing an AngularJS, you'll be able to take away some key components that you might be able to incorporate into your projects. So why exactly are we focusing on modularity? It sounds great in theory. You know, we've got these small, compact modules, but why is it important for you as a Java developer, as a front-end or full-stack developer, or whatever we're calling it nowadays? So let's take a step back and look at examples in the world that we see today. You can buy your furniture in modular pieces. Certain brands are modular, and that's a key thing that sells people. You can reconfigure it. You can do a lot of great things with that. In the computing world, we see parts and pieces as modular components. So through specifications, we can have these loosely coupled components that we can put together and create a system if we're building a PC. On the other end, if you've got a manufacturer, they're still bringing together modular pieces and expressing that as some sort of end product. And I like this example, the cargo ship. If you've ever listened to Docker talk, they actually use this example a lot. A lot of shipping, there were a lot of shipping problems that occurred before we came up with containers, and essentially what we're going to call modules here. But there were a lot of shipping problems. How do I exactly standardize? How do I take an item that's been delivered and then put it onto some sort of freight? So either a train, a truck, or whatever. And the manufacturers came together and decided on some common format that I could now take all of my stuff, load it into a box, and ship it away. And it's a great example of modularity. We can contain things, we can ship them, we can package them up, and we have some concise mechanism that we can build some sort of shipping on. So really, if we define modularity, it's the degree to which a system's components may be separated and recombined. At least Wikipedia tells us that. And the key concept there is that we're logically grouping things. We're logically grouping parts of our application code, and we're separating them out and saying, this is an important feature, and I want to identify that as a modular piece or a component, and I want to reuse it in another system, or I want to recombine it in a manner that allows me to build more complex applications. So really, you're getting those building blocks. And we see this expressed in a couple convenient areas. So I don't know about you if you've ever had a JavaScript application in the past where you're trying to pull together the individual libraries, you're trying to figure out, okay, here's the other dependencies, you know, defining that dependency tree, figuring out that this guy used another GitHub project, that sort of thing. It was really complex there for a while, but if we look at systems like NPM and Bower, we're able to define declaratively a set of modules, and then that dependency trees followed through, and we're able to pull out all the libraries that we need and incorporate them into our application. And that's really great for us. It's an example of modularity. We've designed our code in a fashion that can be shipped and reused across projects. And we can usually use that to build larger applications that accomplish some sort of business goal. But there's a little bit of a disconnect. when we're building applications, why is it that many times our applications kind of become a little bit different? They don't quite look like those libraries that we see. We don't quite get them expressed in a manner that allows us to recombine, even within our organizations. So there's possibly two reasons for that. There's the expectation, and then I'll later on discuss the reality of it. So if I'm developing an application, so let's say an AngularJS application, and my expectation is to build a modular piece of software. So I have different parts of the organization. I've got a large-scale application that I want to develop, and I want to have small modular pieces that in some way come up together and build some sort of structure. So they're small in nature, they're loosely coupled and highly cohesive. Those are two concepts that, especially if we're following the KISS principle, that we really want within our applications. And more importantly, they're easily modified. When we're dealing with the front end, a lot of stuff changes. We've got a lot of assumptions that we may make early on in the project, and we decide our users aren't really satisfied with the experience, or our business group decided that the application needs to go in a different direction. And we want to be able to take those small modules, especially if we're developing in AngularJS, change them or modify them, and then get them to work in a manner that fulfills the original goal or the feature expectation. So the reality of the situation, and I've been on several projects where this usually happens. You start out with a really novel goal. You really want this awesome modular software. You go in with a plan, gung-ho, and then features and requirements change over time. And if you're following Agile especially, in 3 weeks' time or whenever your Scrum period is, you may reevaluate and validate that certain things have changed or new feature sets have come in. And over time, you get something that looks a little bit more like this. Yeah, technically we could stretch the definition and say that it's modular. I've compacted my code in some sort of way. It looks like it has some sort of, definition or structure. Or we could go by the Angular definition and say everything is loaded through module. And what you end up getting is it's not really well integrated. That stack we saw earlier where we could easily put new features in, that's lost completely. You just get this big mess, and it just gets worse and worse at scale. If we're trying to build an enterprise application, especially an enterprise AngularJS application, it's not feasible, it's not practical because you begin to have to sort through the mess. So what happened? Where did we go wrong? We were building an AngularJS application. We came in with our cool designs. We wanted it to be modular. Where was the disconnect? Where did things begin to fall apart? And it's interesting because AngularJS actually, they put it into their documentation. And this is an unfortunate thing that it's not highlighted better. And they specifically tell you that it won't scale to large applications. AngularJS really doesn't care about your application size. Instead, it gives you a framework, and it tells you, that's it. This is all I'm giving you. You need to solve your other problems. But it does give you a couple recommendations. And actually, those recommendations are really key to solving how to scale your application. So the key takeaways from their documentation. Actually, let me stop there for a moment. On this previous slide, if you want to read more about this, the AngularJS modules guide has more information. This is where the documentation link is actually located. So if you're interested, it's this written document. It leads you several different ways through the matrix, and you finally get to the key components of that documentation. And specifically, the key takeaways are best practices for application structure and the AngularJS style guide. And this is one of the key ones, the second point, that is kind of almost frustrating. When you're starting out with AngularJS, the style guide isn't highlighted at all. John Papa is actually one of the core contributors of AngularJS, and he's provided a lot of documentation on a GitHub page that provides all these styles that will make your AngularJS apps more consistent when you're developing them, but also function better at scale. So those are two really key things that we're going to take a look at and kind of dive in as part of this talk. And that was kind of my reaction. So, yeah, like Andy, I figured when I found this documentation, I stumbled on a gold mine. I literally had been working on an application that I was struggling to get over. I had designed it well. I had architected it well. I thought, cool, we've got everything we need. Then the business requirements changed. And I could not scale this application out. It just wasn't feasible. So the net of that, the problem statement, AngularJS provides an MVVM framework. That's it. It drops you off at the door with that. It's not natively built to scale. And it's not natively built to create maintainable software. And I know that's kind of a loaded statement, but it's really true. It says those things are basically the concern of outside, or those are outside the concern of the framework itself. And we need creative solutions to solve that problem. So we really need to kind of dig into architecture and think about it in terms of designing it, and then stick to some concise set of patterns. And you'll find later on that these actually align with where the web is going overall. So, getting started. I don't ever want to see another to-do app. I'm tired of seeing every AngularJS example. Oh, we're going to build a service. We're going to build a controller. Let's do a to-do app. These aren't really applicable to real-world scenarios. If I'm building an enterprise app, I pretty much know how to code a to-do app in my sleep. And it's not applicable for me as a developer for an enterprise organization. So instead, we're going to take a different approach, and we're going to design a Google-like API Explorer. So I'll kind of pause there to actually show what I mean. And I apologize if this is not going to be in the video. Let's see if I can make this smaller. So the Google API Explorer is maybe something a little bit closer to what you'd see in an enterprise scenario. You want a clearly defined way to discover your API. So I've created a set of APIs in my organization. I want to explore what those APIs are, and I also want to know the operations that are available. So this is maybe a little bit more applicable than a to-do app. And it lists all of the services that are available. So I assume there's a dynamic component. I can register these services somehow. And then when I dig into these services, I can individually see the individual operations available. So some sort of description and some sort of understanding, let's see, is it underneath here? Some sort of understanding of how this operation works. It's a little bit more extreme than we're going to go, and I'll show you what the project kind of looks like. So this is available as part of the code, the sample code that is available on my GitHub, and I'll call that out in a moment. But we're going to be building this. So we're only going to take a portion of that API Explorer. We're going to break down what it requires to build this in a modular fashion using AngularJS. And if you see, we've got all of our services listed. And if I dig into each of the individual ones, I get some sort of sense of a description as well as the available operations for it. And if I go back to my services, one other key component to call out is this Echo API is something that I dynamically registered. So these two are part of my sample set that's loaded in as part of the application. But Echo API is actually being pulled in from an external library. So it's a key thing that, you know, if I wanted to break apart my application and have separate teams working on it, it's something that I can now do. Okay, so this is the GitHub I was talking about. If anybody wants to follow along, it's a little bit long, github.com/tato123. And then underneath that, I've got my repositories, so you can either choose to browse or go directly through Angular-modules-presentation. Okay, so the API Explorer. We kind of looked at what exactly it does. We saw it running on Google. A couple things to note about it. It's built with GWT. You know that thing Java developers swore was going to take over the front end. You're going to be able to do everything, bake a cake, whatever. You could do all of those great things in Java. So we'll leave that one there. We can browse the REST services and their operations, and more importantly, the extensible component. So we're only going to tackle two parts of it. Like I said, we want to tackle browsing the services. And we really need to define what exactly we say when we're browsing the services. I want to be able to list each of the API services. And then I want to be able to register a set of APIs, whether that be statically or dynamically through AngularJS. And then I want to be able to browse the operations. So once I have those set of services, what are the operations that are available? And then I want to be able to register those operations as well with a given service. So they're associated and tied together with that service. So we're going to kind of take the approach as an architect, as someone designing a new service. We're going to go through the steps of what are the key things that we need to consider for developing this application. So some of the key things that I think about, and you can take this in any order you'd like when you're developing your application, but structuring our application, loading the components. So specifically, we need to have some means, once we structure our application, to actually identify those pieces of code and load them into our application's index file. We want to have code consistency because it's not going to be maintainable. It's not going to be modular if everybody writes code a different way. We need to have some sort of baseline common set of standards. And then if we're good developers, we want to test this code. We want to have some means of, with these modules that we have identified, we want to have some way of testing them. And then finally, that component where we were talking about adding in dynamic services, we want to be able to extend this. So we defined a set of modules. We want to pull them together somehow. And then we're going to go ahead and define some terms. So when I move forward with some of the discussion, there's three key areas. So a component is going to be the actual realization. So when we create a folder structure, a file, whatever have you, that's going to be the component part. The feature is, what exactly are you trying to accomplish? If I've got some requirement that my product owner, that product management asked me to build, that is more so the feature set. I have my feature and I need to build a component off of that. So the feature is kind of the logical piece. The component is the actual manifestation. And then the module is, in the context of AngularJS, it can be either a single component or a collection of components. So one of the interesting things, well, let's take a moment. When we're structuring components, let's start with what we have in AngularJS. If you've ever opened the AngularJS quick start application that's available, there's a Yaman template available for it, or if you go through some of the documentation available on the front page, you'll notice that they break things apart by AngularJS functionality. And that's really aggravating. The first thing I thought was, hey, I've got all this great JavaScript, and now I'm associating it to AngularJS. Everything that I write is now tied into that framework. And if AngularJS dies, so does my code. I have no other way to identify it. But that's probably not the best way to think about it. The more I kind of considered it and actually working with other individuals in the company, this is really great for getting started. I'm not going to use this as a pattern to build out a large-scale application, but it's okay to use when I want to take a junior developer or I want to take somebody who's new to AngularJS and walk them through the concepts of AngularJS. Here are the key pieces, especially if you have developers that are coming from different language sets and being introduced to things like promises and eventing overall in JavaScript. It's great for identifying where those things fit that they've heard about on the web within an AngularJS application. And I like to call this the function-based structure. You've got each of the functions within AngularJS, quite literally described as functions in the AngularJS library, represented as part of the folder structure. So we take these theoretical foo and bar features that we want to build, and we've got them separated out by their AngularJS functionality. And there's an expectation there that now that our features don't have any sort of component around them, we have these functions, we need to rely on some sort of consistent naming scheme. So basically within our files, we're identifying what are the features we're trying to build. And it's really challenging when we want to take this structure and scale it out 4, 5, 10 modules, which is the case when you start building large applications. It's really hard to do that. Your application now relies on looking through different folders, different files, trying to identify where these things land. And depending on your IDE, that can be really tough, especially if you start nesting. So the key things. There's an implied coding convention with that function-based structure. It's not called out in their documentation, but because there's so many rules that kind of govern that function-based structure, it's kind of implied. Each file needs to be named in some manner that identifies your features. Otherwise, you have no way to understand what exactly that component or that file comprises. What exactly are you building? What are you doing in there? And the other key part, so concise naming. I don't know about you, there's plenty of times where I've messed up naming a file. There's plenty of times where I've come back and realized what I wrote at 2 a.m. in the morning, the name is ridiculous, it makes no sense, and I need to go back and actually update that to more accurately reflect what my feature is. The other part of that is everything exists as part of AngularJS. If I was to say that this code does anything, it's really hard to define what it is it's doing. If I said that I have a browse operation with this function-based structure, it doesn't really make sense. What you have is an AngularJS operation that then realizes a feature, rather than a feature that is realized by AngularJS. It's a subtle change, but the function-based structure is really just saying that you've got some sort of AngularJS code that's doing your work, rather than you kind of having a feature that is realizing that work. And finally, the test coverage. So we've got independent features. We want to be able to identify what are the collection of classes or JavaScript files that we need to test to say that this feature is complete, it's 100% tested, it looks good. So the next possible structure is feature-based structures. Feature-based structures are a little bit different, and they're based off the lift principle. So that John Papa style guide that I mentioned, each of the styles are numbered, and this is Y140. And it's critical to kind of building that first layer of modularity. And we have 4 key components of that. Locating our code is easy. So I don't want to flip through my code constantly back and forth. If I'm working on a browse feature, I should be able to quickly open up that feature, modify and make changes, add services, add the controllers, and be done with it. In a distributed environment, this works really well. You can isolate your developers to pieces of individual code and have them work on that. And you can really track the progress a lot easier. The second part of this is identifying the code at a glance. This one, you kind of see it in the function-based examples that AngularJS provides. This is really more about having a consistent naming convention behind your files. So post-fixing your files with dash controller, dash services, so you can identify what is it you're trying to accomplish, what are you trying to expose within this individual file. So, sorry, Siri. Flat structure. So when I say this, it'll be more apparent in the second graphic that I've got for you. But this is kind of a little bit different. If you come from an object-oriented background, especially Java, you're used to these very long, extensive Java package structures where everything's very deeply nested. We want to avoid that with the lift principle. And when you think about it from a UI perspective, it really makes sense. I've got parts of my application that are exposed to my user. I've got this awesome box that has an even better animation than Google, you know, and I want to expose that as better Google animation. I don't know. Some sort of arbitrary feature, but that should be individually realized. Why do I need to include this within a sub-package for all my divs or components or everything that's, say, a widget? It really is its own standout feature, because when I get tired of it, I just want to rip it out of my application. I want to be able to easily identify it. But also, if I'm working on it, I want to be able to find it easily. And then try to stay dry. So this is a little bit different. There's a lot of purists out there on the dry principle. This is really kind of a halfway point. With UI applications, it's very easy to go down this black hole that everything is common, and what you end up building is many, many, many different components that try to simplify or create over generic pieces of code. And what you find maybe later on is that you had an assumption, some sort of assertion that was wrong, and you really didn't need to overgeneralize it. Furthermore, you might also have a situation where you have a dialog box that's very specific, and you think, man, I'm going to use this everywhere in my application, and you realize it's not that useful. It's only relevant to one individual component. So what I say there is try to develop your code atomically at first, and if you find that it's common, that it's shared, then make it then isolate it as its own component so that you can follow the dry principle. So feature-based structures. We're going to realize the foo and bar modules that we talked about earlier. I don't know if that clearly shows. Yeah. So we've got foo and bar, and they are their own components now. So we've got the feature is foo as some sort of component that, product management, product owner has decided, hey, you need to implement this within our application. That's our feature. The component is some sort of folder structure, some sort of structure around that. This no longer relies on any sort of file naming. You now have a folder that realizes that feature, and we call that a component within AngularJS. And then this is starting to get us consistent with node projects. If you're familiar with node projects, this starts to get more in that realm of I've got packages that I want to build and use and identify. We're starting to get closer to that with this sort of structure. And you'll find that it's actually relevant as we begin to move on and package these modules. So the application structure, we've got these different components that we want to create. So we've got app, browse, operations, registry, and then a mock service. So as I mentioned, the component is the realization. So it's this folder structure that we've created. And then individually, these things expose, so these are now our components. Individually, they identify the pieces of the application. Now, I'm not saying that every application you build, you're going to have all of this structure prepared. I actually discourage that. Do it in a progressive manner. When you find out you need to build a feature, that's when you would build your component. In this particular example, we're going in knowing that we need these 5 fundamental features. But if we wanted to extend, if we wanted to add another piece to this code, then we would add that 6th component. We shouldn't try to over-optimize or try to build out components that we don't have any sort of actual value proposition for. So that's kind of the first part. I'll actually pause there for a moment. So that's our folder structure that we're going to build. We haven't put any code in it yet, but we've identified here are the components that we want to use. So loading our components, we've got these features and we want to get value from them. We've created a component for it. I want to be able to now load them up into an application in a consistent manner. So if you're familiar, this is what your normal AngularJS application will look like. I've got each of these individual JavaScript files. They would normally be packaged in some sort of either function-based structure or even, say, feature-based structure. And they're just a bunch of different JavaScript files. Luckily, AngularJS is lazily loaded, but still, I've got to identify all those individual pieces of JavaScript code and load them in through my index.html. That's not really friendly for a couple reasons. So this definitely gets us into a scenario where we have merge conflicts on our index.html. When you're working in any sort of enterprise environment, if you're building an application at scale with a lot of developers, it's really hard when you've got one resource under contention. You're constantly having to go through merge conflicts. And there's different solutions out there, such as dynamically going through your folders, appending those to your index.html, all the scripts. So there's lots of different build tools, but it really is starting to get into an environment where there might be a better way to do it. This also declares the universe of scripts. So we haven't really identified what exactly is valuable in our application. What are we using? What's dead code? The index.html or any IDE isn't really going to say, OK, I've seen that you've loaded all these scripts, and I need to go back and tell you, I need to go and check where you're actually declaring, some sort of call, mind you, through AngularJS, so it could be a dependency injection or whatever, and then tell you, OK, this script is actually dead. It just really doesn't happen. So we're not tying back to components as well. When I say that, it's basically we've created all these great components through our application structure, but I'm not saying I want to build a browse. I'm saying I want the files of browse. So I want some sort of mechanism that allows me to identify the component and just use that component. I really don't want to know what it takes to build browse or build registry or build the search, any of the other components that we've identified. I just want to say that those are parts of my application, and I want to somehow load them in. And then when we get to testing, we're doing this all over again. So if you're familiar with Karma, we've got to take all of those lines from our index.html, and then we've got to load all those same files back into our Karma file. It starts to get really nasty. If you're developing any sort of application that's big, and especially at this point, since we don't really have a mechanism to extend it out, it just starts to get really nasty really fast. So what do we want? I don't want to have merge conflicts on index.html. And that doesn't mean that I want to have some sort of mechanism that scans through all of my folders and pulls out all of my files. I truly want some sort of mechanism that completely eliminates any possibility for a merge conflict. I want to use the component structure. So I talked about Node.js already kind of provides us some sort of mechanism of saying, I want this package. That's what I want. I want a feature like that. I want to declare dependencies. So this kind of goes back to the component structure. I want to tell you I need browse. That's it. I don't care what the files are underneath it. This is what I need for my application. I know that Angular exposes some sort of module API, and it's got a namespace associated with these files, and I should be able to dependency inject these files. But that's a little bit more. I don't want to deal with any of that. I just want to pull in my files. That's as far as I am right now. And then I want to have it done automatically. I want to have my cake and eat it too. The build tool should do it. I shouldn't be going in and changing any files. So the solution to that is a tool like Browserify. Now, this is definitely not your only option, but this does allow us to use CommonJS. And I know there's other sorts of tools out there that will build the universal module definition, of which CommonJS is one of those. But Browserify is pretty straightforward in terms of a grunt and gulp task. It is something that I'm familiar with because our project uses it. And it is pretty easy to get started with. And there's a lot of transforms and things like that. So the project does bring a lot to the table. The nice thing is that Browserify supports NPM modules. So if you notice, with AngularJS, the versions after 1.2, all of the packages are actually available on NPM. And if you look at AngularJS 2, everything is exposed through there. A lot of things are actually getting exposed through NPM. And it goes back to that universal module definition. Yes, we can pull it in through the standard library mechanism, but they go ahead and expose the CommonJS syntax as well as other couple formats. And this will allow us to support the features that we've built in as components. So if we look at our components, these are the things that we want to load. I've got some sort of structure already defined. I've got application exposed as a module, and then I've got other components underneath it. So the second step for us is taking that structure and loading it in declaratively. And to do that, we're going to follow the Node.js syntax. We're going to expose an index.js. This is what's going to export our functionality. And then we're going to pull it all together through that application component. So really, at this point, application is just another module. When we say we've got an ng app, it's really we're exposing some sort of AngularJS functionality. It could be as large and extensive as an entire SPA site. It could actually be something small. It could be this great new widget that then gets loaded into someone else's application. So you can really start to have many different unique combinations. And what that looks like is I can simply require my components. So you'll notice a difference, a slight difference in these two declarations of require. So external libraries that are loaded in through npm have a slightly different syntax. And that's just because our internal modules, and I apologize for the spelling error there, I caught it afterwards, but the internal modules are being loaded relative to our current path. So we have that index.js, and we're going to pull those components that are co-located with us. And then we've got the Angular UI router, which is exposed as an npm module. So we've used our package.json, and we've pulled in this external dependency. And we can, for this application root, we can set up a configuration. So if we dig into browse, now we're kind of getting into the coding aspect of loading components. We've got a controller that we've defined for browse, and we want to pull that in. So we're doing a couple things here. We've declared Angular UI router, and in browse, we've got a set of routes that we're going to dynamically append. So we've got a set of new URLs that we're going to expose. And then we've got a controller that is going to basically work with our browse.html to expose the view model. And then we've got that pesky HTML. So if you remember correctly, our index.html had all of those dependencies listed. We don't need to do that anymore. So when we move to this sort of structure, we've got one file that we're loading in. So all of that is pre-processed. We've got a bundle.js, and we're able to pull in declaratively all of our code. And if we're using a build tool like Grunt or Gulp, all of that is being dynamically compiled as we make changes. And if you are in a development environment, I strongly encourage you to turn on source maps. What you get out of that, you'll basically have all the same structure that you had before, and say you're using the Chrome debugger tools. You'll see all the source, all the subfolders. You'll still be able to track everything as it is in your project. So you're not seeing the concatenated file. You're actually seeing the breakout of it. Code consistency. So this is what I kind of talked about. If we're not all on the same page, there's no effective way for us to write modules. We've gone through structuring our application into something that looks modular. We've gone through loading it declaratively, but now we want to make sure that each of the pieces we write is actually consistent. This is a little bit more AngularJS, but you'll see that it kind of appeals to people who are used to more pure JavaScript. So a couple of the key styles that are going to be important if you're starting out with AngularJS modularity are these three styles. We want to make sure that we've only got one component per file. If my file is a controller and that's what I'm exposing, that's all that should be in there. Don't append services, don't append configurations or constants. Create a new file for it. And it may seem like you're going to get a really exploded out application, but it's actually pretty consistent with the other languages when you think about it. It's kind of the equivalent of just having a singular class. Avoiding naming collisions. So this is more about identifying your AngularJS modules. So within that naming syntax, where you have angular.module, and then you provide a namespace, make sure that it's something that describes what exactly you're exposing. So that component. If my application is called namespace app, and I want to expose a browse component, usually you would do that through a dot notation, so it should be app.browse. And that way we can avoid our naming collisions. And then using named instead of anonymous functions. So this is an interesting one. The Chrome debugger tools are unique. They help you out if you help them out. If I wanted to debug a situation within my application, it's actually easier to debug it if you use name functions. That's one good reason to use them. Another is that the anonymous functions aren't easily exposed through, well, they can easily become inconsistent inside of this new world. And that's more around the Angular.controller, and then I've got a sub-anonymous functions. It can really get a little awkward when you want to export that particular function and you want to go to more a JavaScript-based syntax. And like I said, this is a small list of what's available. I highly encourage you to go through the code style guidelines. But we can see here, so one component per file. It's a little bit challenging, I'm guessing, to see, but basically I've exposed a browse controller, and inside that browse controller I have a declared function, and then that function is being exported. So there's no anonymous function there. And that will, if I'm going in use strict mode, makes it a little bit easier to go through and process for any strict violations. Now the nice thing is, if you're using Browserify, it also guards you because none of this is being leaked into the global namespace. You're automatically getting wrapped into basically IIFE, immediately invoked function. I'm going blank, but you know what I mean. So the benefits, again, are kind of small focused functionality. It's a little bit easier to read. If I've got a lot of different functionality exposed, a lot of different components, it becomes really hard to kind of track what's going on. It's a little bit easier to debug as well. When I get some sort of error that says, I have an error on line 152 or line 12 of my controller, I'm not having to compete and look through services and things like that. And then finally, it's a little bit more portable. I can rip out controller code, I can extend it, I can add new things because now I can identify it. And that's realized through this browse controller. So one key thing to call out, the index.js contains your Angular syntax. So I expose Angular.module and .controller, config, all of those things separately inside of index.js. And if we look back actually for one moment, there's nothing in here that really screams AngularJS. These things could easily be parameters that are passed in. And if I follow a couple more of the style guidelines, it actually gets you to that point where you're essentially ripping out most Angular code. And it's really nice. And you look at the first examples from the AngularJS website, that's actually how a large part of it is written. You're not exposing a lot of Angular pieces of your code. So you can kind of write it in a more pure JavaScript format, and then, after the fact, expose it as AngularJS. So the second part, I have this registry, and I want to be consistent. So I've got a provider, essentially. I've got this provider that I want to expose. I want it to register new services. So this kind of gets into that conversation again about anonymous functions versus function declarations. So if you see, I've declared the this.get, $get, and if you're familiar with AngularJS's examples for providers, traditionally they'll have you declare it in line. In this particular example, we've declared it separately as part of just the factory method. Now, we only did this because services and factories are a little bit different. When we've got a factory, we would expose just that function. We wouldn't have these sub-functions really as a part of the main service to expose the main service code. In this particular case with the provider, we've got the provider that's exposed, which then in turn exposes the factory. And it's just kind of a syntactical thing because of AngularJS. But otherwise, it's very similar to our controller. So moving on to testing components. We've done a lot of great things to try and get our code structured. We're trying to load it declaratively. Now we need to test our components. And that's definitely a lot easier with modules. So this is kind of where I touched on. With Karma, traditionally you would need to list all of your files. It's actually pretty straightforward. Same sort of scenario as the index.html. You're not having to declare all of the AngularJS files that you're going to be loading in. You just declare your bundle.js. And an optional tip, try and co-locate your test files or your spec files with your actual components. It makes it a little bit easier when you're trying to identify, if your module is completely 100% tested, or excuse me, if your component is 100% tested, you can really begin to see and realize, okay, I've written test cases for my provider, I've written test cases for my controller. I can really start to build my build tools individually and pass individual components. Or if I've got a collection of components that identify a module, then I can really begin to test those things and provide some sort of test metric against it. So it's very helpful from that perspective. So we've got testing down. We've got some sort of mechanism now using Browserify. We can begin to test those things. Finally, we want to extend it out. So really the value is we've got everything working within our application, and all of this, again, is available through the sample code. I really encourage you to kind of go through it. I'll help to explain some of these things maybe better than I can. But the extending piece, we want to take these modules and we want to split them apart. So I've got a team locally, and then I've got a team located halfway across the world. And they maybe have a better expertise at some part of the application. I want to give them the capability that they can write their code in isolation. They can test it, we can certify that it's good, and then I want to incorporate it back into my application. And I mentioned that Echo API kind of being that. So if we look at the individual pieces we have so far, we've got components, and these components are represented as small atomic pieces. They're loosely coupled. We've accomplished that goal. And then the components are in some sort of format. They're in common JS syntax, which allows us to use node modules and pull in pieces of our application. We actually saw that with the Angular UI router. All we need to do for defining a new module, so assuming that I create some sort of new Git project, I just need to declare a package.json, and then I can start working with my components, and I can expose that. And now the tools, the features, whatever is being exposed by this third-party team can now be absorbed into the main Angular application. So you really can start, think of your application as small atomic pieces that can be farmed out. You can work it in a distributed fashion, and you can begin to pull it together as a collection rather than large-scale AngularJS applications that you've got to worry about each of the individual pieces coming together. So like I said, you can pull in modules. Another consideration if you're using a private registry. I know, for example, Artifactory exposes that. You can begin to link these in with your continuous integration tools. So if another team is working on exposing a service, those can be published up to, say, Artifactory, and now you can pull those down. And you don't have to go through the cycle of pulling in partial code. You could get the latest stable version. So wait until they actually publish the new version that works better rather than incremental build, which you would see if all of these were co-located in the same code base. You may have instances where things are partially working, not really working. I don't really deal with that. If I'm working on the core application, I only want stable pieces of code. And again, this kind of goes back to that independent testing. We don't want to test our modules together. We want to test them as small atomic pieces. We also want to version them separately. This allows me to declare, okay, I'm actually ready for you to consume whatever I've built. Your AngularJS application can pull in this piece because I know it's not going to display something really wrong to our users. And this is kind of a couple more points on maintaining and versioning. Kind of the same points about testing and versioning separately and focusing on the smaller pieces of code. So this new API that we're planning on building, we can export it. All I did in this particular scenario, and actually I can pull up the code for a moment because I don't think I have an example here otherwise. So we've exported this configuration. We pulled in the API registry provider that we built earlier, and this is separate. Keep in mind that this is a completely separate module. All I'm saying is that when this runs, something needs to be defined as API registry provider, something needs to be injected into my function, and then from that, I'm assuming that there's a register function available. So we can kind of separate things out. you can lazily say that there is going to be some sort of API registry provider. If I'm testing this, I obviously have tools in Jasmine and things like that to spy and mock things. So we've created that configuration. We defined our package.json. So everything is isolated. It's been uploaded to Artifactory. And then in the core project, I've gone and added it back. So in the core project, I say npm install on this Echo API. And I save that as part of the core project's package.json. It's pulling it down from my private registry, and it's all integrated. And at runtime, it pulls it all together. So we get something like that example that I provided you earlier. This is what we started with before we add the Echo API. And the moment that I install the node module for Echo API, actually, these are a little out of order, we get something like this, where it actually appears. And the nice, convenient thing is that I can do this when the application's up and running. I can just run npm install, and then all of a sudden, my application will recompile once I've declared that dependency, and I'll see this. So that's what this is basically calling out, is that we went from requiring the Angular UI router to requiring the Echo API because it is an external library. OK. Brief point on the future. So AngularJS 2 and ES6 definitely has been a hot topic. Where does this fit in that? So within AngularJS 2, they're actually making heavy usage of the ES6 standard for modules. And you'll see that exposed as a core piece of the framework itself. All of their examples are built upon defining a component and then pulling in these separated modules. The core library itself is addressed in this way, fashion. You'll see statements for import Angular, and you have to use that for defining any sort of logic within the AngularJS 2. So this approach is actually almost synonymous with what's going on within AngularJS 2. And if you want to get really crafty, you can actually do in-place conversion of your AngularJS to AngularJS 2 projects like this. Because if I don't really know what's exposed by a component, I can begin to rewrite parts of it where either it can be a AngularJS 1 or 2 compliant component, and I can export it out as a module. So here's my Twitter. If you have any additional questions outside the scope of this conference, you can hit me up at any time. And then here's my GitHub. OK. Thank you very much for your time.